Hi, good morning, everybody. My name's Tyler Jackson. I'm the director of the Koch Institute. It's my pleasure to welcome you to the 2018 edition of the Koch Institute Annual Symposium. This is the 17th year that we've organized this event, and we do so to feature exciting, important, emerging areas of cancer science and technology. And certainly this year's theme is no exception. We're featuring this year nanotechnology and its applications to cancer diagnostics, detection, imaging, and therapeutics. This is a very important area of cancer technology and engineering and its applications to all of those aspects of cancer care and cancer biology. It's also one that we care deeply about at the Koch Institute. I think from the early days of our discussions about how to organize the Institute, we recognize that here at MIT we have great strengths in nanotechnology, and we indeed recruited a world-class team of nanotechnology experts to join us as we developed the Koch Institute, and we'll be featuring many of those individuals in talks and in the panel discussion over the course of today. I want to thank especially the organizers and chairs of this year's symposium, Angie Belcher, Sangeeta Bhatia, and Paula Hammond. I want to call special attention to Sangeeta, who sort of took the lead amongst this group. Sangeeta is actually the director of a new initiative that we have at MIT and in the Koch Institute called the Marble Center for Cancer Nanomedicine. And this is one other indication of our view of the importance of this area, not just for the Koch Institute, but for cancer research more broadly. We're grateful to Kurt Marble, who provided the funds necessary to allow us to establish the center. And as I said, you'll be hearing from many members of the Marble Center over the course of the day. We've received a great deal of support in putting this symposium together. I want to call a special attention to our diamond and gold level sponsors, Thermo Fisher Scientific, Johnson & Johnson Innovation, and Sanofi Oncology, but all of our sponsors who provided funds necessary to cover the cost of the symposium. We're really grateful for this year's support and really your ongoing support after all these many years. We also have a series of vendors who have tables outside, and I would encourage you to patronize them during the breaks and during lunch to show your support of them as well. Thanks also to our speakers, not just my colleagues from MIT, but those who've joined us from around the country and indeed around the world. We're looking forward to hearing about your work and your insights and your perspectives. Thanks very much for being here. And without further ado, let me turn things over to Sangeeta Bhatia, whom, as I mentioned, is the director of the Marble Center for Cancer Nanomedicine, and she'll take us through the rest of the day. Sangeeta.
Tyler. Welcome, everybody. Good morning. So today, we are going to hear something along the lines of challenge, meet opportunity. And the challenge, of course, is the global cancer burden, and the opportunity for this day's conversation is going to be nanotechnology. So I wanted to just share a few sort of opening thoughts, and then we'll get started with our morning session. By way of sort of framing the conversation, this is actually a recent report that came out in the Lancet Oncology, talking about future cancer research priorities in the US. This really helped to document some of the recommendations of the Biden Moonshot Commission that some of our faculty led, and many of them participated in this report. And you can see here what the recommendations of the report are going forward for future cancer priorities, but a couple in particular that I think are opportunities are prevention and early detection of cancer. We know that outcomes are better when you find cancer early, and development of new and enabling cancer technologies. So the data on early detection, improving outcomes, I think are familiar to many of you, but for those of you who are engineers in the community, this is a nice recent review from The Economist showing virtually every cancer, every solid organ has better outcomes when it's found localized before it's been metastasized. And we know that this is actually going to be very challenging to bring out to the global community. So early cancer detection has some existing strategies, but it turns out that the global burden of cancer is increasing at alarming rates. You may know that cancer globally claims more lives a year than TB, HIV, and malaria combined. But actually, in the sort of coming couple of decades, the low and middle income burden of disease is really going to swamp the burden that we see today. And so over 70% of these cases are going to be in low and middle income countries. And if you really think about how we do cancer detection in that setting today, these are images from two of my former students who are now both physicians, Alex Bagley and Mary Zhu, who spent a summer in Botswana. And you can see on the left here, this is Cancer Grand Rounds. He's looking there at a plain film. And on the right there is the diagnostic clinic for the country, which has intermittent power. And so we start to think about how are we going to detect cancer early and earlier globally. It's actually an enormous challenge. And in that context, I think we have some amazing opportunities that nanotechnology can help address. So for those of you who aren't used to thinking about sort of the nanoscale, this is the classic engineering curve, the so-called Moore's law. This is the number of transistors that you can fit on a unit area of a semiconductor chip, and it has been doubling every 18 months for some odd years. And what's notable about this curve is that in the year 2000, the smallest feature size that you could make on a chip actually dropped under 100 nanometers for the first time. For me personally, this was a really exciting moment because it happened to be the year that I graduated from medical school. And so there I was with a whole career ahead of me and now access to the nanoscale from a fabrication perspective. We call this top-down fabrication, but there's also bottom-up fabrication where you can make nanoscale materials through chemistry, and you're going to hear a lot about those today. And what's so exciting about that is that this length scale, this sort of 10 to 100 nanometer length scale, is in fact the precise length scale at which we communicate with the body. So a single receptor is 10 nanometers, and viruses are 100 nanometers. And so now we have a whole repertoire of tools, really, that can think about communicating with biology at the relevant length scale. So it's a really exciting time, and there's a lot to do. Here in the US, this field has been propelled forward over the last decade, actually through federal investments at the NCI and elsewhere, the National Nanotechnology Initiative. And this is just a timeline to show you the kinds of things that are emerging from the field. So here at MIT, we thought it was really a perfect time to coalesce these kinds of activities in the Marble Center for Cancer Nanomedicine, because on the one hand, we have this wonderful institute that Tyler told you about, the Koch Institute, which is a set of engineers and cancer researchers working together. And on the other hand, we're about to launch, and you'll hear about this later today, MIT Nano, which is a new nanofabrication facility that's going to serve about 2,000 researchers. So it's an incredibly exciting time for us to bring together challenge and opportunity. I hope you have a great day with us today. You're going to hear from some of our Marble Center for Cancer Nanomedicine researchers and many other outside speakers. And so I think we're going to have a great time.